Hey guys, and welcome back to another video. In this video, we'll be talking about trig identities. This is going to be part 1 of this section. Alright, so let's get into it. So to begin with, let's start with the Pythagorean identities. Okay, so let's start with the unit circle. Okay, so when I do these trig identities, I'm going to be like building most of them. So that's why you don't have to like actually memorize the identities. Just like memorize how to build them. Like just like know how to build them. Because I feel like if you know how to build them, then like you can automatically just create the trig identities yourself, right? So there's no need to memorize these. But anyway, to begin, let's say we have this reference triangle, the unit circle, right? So we'll say this length is x, this height is y, and then the hypotenuse is 1, and then this angle is theta. Okay, so sure, we all know the Pythagorean theorem, right? A squared plus b squared equals c squared, where a and b are the legs of the right triangle, and then c is the hypotenuse of the right triangle. So let's apply the Pythagorean theorem to this triangle right here. So we have x squared, right, plus y squared equals 1 squared. So this is just x squared plus y squared equals 1. All right. But then recall how cosine of theta is equal to x and sine theta is equal to y. And so then we could substitute those values in for x and y in here. So x is cosine theta, so we have cosine squared theta. And then y is sine theta, so we have sine squared theta equals 1. And this is the first Pythagorean identity. So cosine squared theta plus sine squared theta equals 1. Okay? And then we have two more Pythagorean identities, and to get those, you just can derive them from this Pythagorean identity. So the way we're going to derive the first one is let's just divide everything in this equation by cosine squared theta, right? So let's see what happens if we do that. So if we take cosine squared theta plus sine squared theta equals 1 and divide both sides by cosine squared theta. So you have cosine squared theta over cosine squared theta, that's just 1. And then we have sine squared theta over cosine squared theta. So remember that tangent of theta is defined as sine over cosine, right? And so therefore tangent squared is equal to sine squared over cosine squared. So sine squared theta over cosine squared theta, that's just tangent squared theta. And then 1 over cosine squared. So we know that secant theta is 1 over cosine. So then therefore secant squared is 1 over cosine squared. So this side just becomes secant squared. So this is the second Pythagorean identity. All right, and then there's one more. And to get that last one, instead of dividing everything by cosine squared, divide everything by sine squared theta. Okay, so let's build that one too. So we have cosine squared theta plus sine squared theta equals 1. And then divide everything by sine squared theta. Okay, so cosine squared over sine squared. So that's just the reciprocal of this, right? So it's the reciprocal of tangent. So if you recall, cotangent theta is 1 over tangent, and so then that's just cosine over sine. Okay, and so then therefore cotangent squared is going to be cosine squared over sine squared, which is exactly this first term. So we have cotangent squared, and then this is just 1. And then 1 over sine squared, again, recall that cosecant theta is equal to 1 over sine theta, right? And so then, again, therefore, cosecant squared must be 1 over sine squared. So then this side just becomes cosecant squared theta. Okay, so yeah, these are the three Pythagorean identities. All right, cool. So now let's do some practice problems using these Pythagorean identities. Okay. So, example 1. So let's find sine theta and cosine theta. If tangent of theta is equal to 4/3 and theta is in quadrant 3. Okay? So how do we start this problem? So we want to find sine and cosine, right? So we're trying to look for an identity that relates tangent theta to either sine and cosine directly or the reciprocal. Because if we can get, like, for example, tangent to like one of the reciprocals of these functions, then we take the reciprocal of that and then we get the function. So either the function or its reciprocal, doesn't matter, we can still get the original function. So then let's see. So we know that the reciprocal of cosine is secant theta and the reciprocal of sine is cosecant theta, right? And so then let's write out our three Pythagorean identities. Okay, so these are the three trigonometrics. So we're given tangent, and we can find secant using this identity. So I'm probably going to use this identity first to find secant, and then take the reciprocal of secant to get cosine. And then once we get cosine, we can just put it into here. But I'm going to explain why that's a bad idea in a second. But first, let's just use this second identity right here. So we have 1 plus tangent squared. So I'm going to write it again. 1 plus tangent squared theta equals secant squared theta, right? Okay, good. So we want to solve for this. So let's just solve for secant theta first. So it's plus or minus the square root of 1 plus tangent squared. So two things, right? So first we have to like determine whether it's positive or negative. So theta is in quadrant 3. So this is where the ASTC comes into play again, right? So we're in this quadrant right here. So in quadrant 3, we know that tangent of theta is positive, and then it's reciprocal, so cotangent of theta is also positive. But everything else is negative. So that means that secant is going to be negative. So you want the negative square root. Okay? And then you just substitute in the value. So secant is equal to negative square root of 1 plus 4/3 squared. And let's see. So you get like, this is like 16/9 plus 9/9, so that's 25/9. So negative 5/3. So secant of theta is negative 5/3. All right. So good. So we found secant theta, and then to find cosine, we just hit the reciprocal. So if we have our answer box right here, we take the reciprocal of this, and you get negative 3/5. So cosine theta is negative 3/5. All right, good. So now you can either take this value of cosine and then go to like your first trig identity and solve for sine, right? That's okay. But the problem is like, let's say you made a mistake in this one, that means that your cosine theta value is going to be incorrect if you made a mistake. And so then if you just use that value again in this, that means that sine is definitely going to be incorrect. So in order to like avoid that like error, to like mitigate like the amount of mistakes that you make, I would recommend just like using whatever the problem gives you for finding each of the trig functions, right? So that's why maybe let's try using the second identity, right? Because you know that the reciprocal of tangent is cotangent, and then the reciprocal of sine is cosine. So then we can use this third identity to find cosecant, and then take the reciprocal of cosecant to find sine. And yes, there is some error when taking the reciprocal, but I'm pretty sure we're all really comfortable taking the reciprocal. So like the error there is like much less than the error in like this, because here you have to determine the sign and you have like a bunch of messy square roots. So the error is much greater here than just taking a simple reciprocal, right? So that's why I'm going to use the third identity and then solve for cosecant and then take the reciprocal. So I'll do that right here. So we have 1 plus cotangent squared theta equals cosecant squared theta. All right, and then solving for cosecant, we get plus or minus the square root of 1 plus cotangent squared. And again, determine the sign. So we're in quadrant 3, so only tangent and cotangent are positive, meaning that cosecant is negative. And then substitute in. So cotangent of theta, that's the reciprocal of this. So the reciprocal of tangent is 3/4. So cotangent is 3/4. And let's see, you would get negative 5/4. Okay, so that's cosecant. And then again, you want sine, so you just hit the reciprocal of this. So therefore sine is negative 4/5. Okay, good. So this is the answer. All right, let's do one more. Let's do another example. All right, so now we want to find the values of all the 6 trig functions. Find the values of all 6 trig functions if sine theta equals negative 2/3 and theta lies in quadrant 3. All right, cool. So I'm going to make my little answer box on the side here. And then we have cosecant, secant, cotangent. All right. So we already know what sine theta is, right? That's given in the problem. So it's negative 2/3. And then if we take the reciprocal of sine, we get cosecant. So we actually already know what cosecant is as well. It is negative 3/2. And then, but to find the other 4, we need to use our identities. All right. So right off the bat, we can use our sine squared plus cosine squared equals 1 to solve for cosine. And then once we get cosine, we take the reciprocal to get secant. So notice how once you have one of the trig functions, you automatically know another one because the other one is the reciprocal of that one. So that's a pretty cool thing about these. So you don't have to like do an identity for each trig function, only for like 2 of them, and then you get the other 2 as well. All right. So you want to solve for cosine theta. So we have cosine theta is equal to plus or minus the square root of 1 minus sine squared theta. And then this is where we have to determine the sign. So let's do ASTC. So we're in quadrant 3 again, right? So in quadrant 3, tangent is going to be positive, and then cotangent is going to be positive. But everything else is going to be negative, so cosine is going to be negative. So this is negative. And so now let's substitute in. So we have sine is negative 2/3. And then let's see, you will get negative square root of 5/3. All right, so cosine theta is negative root 5/3. And then taking the reciprocal of that, secant is negative 3 square root of 5/5. All right, cool. So now we need to find tangent. But I feel like it might be easier to find cotangent first because we have the identity 1 plus cotangent squared is equal to cosecant squared. So if we try finding tangent first, then we have to use identity that 1 plus tangent squared equals secant squared. But then to find secant squared, we have to use cosine, but our cosine might be wrong, right? Like it isn't, but like if you were doing it, like it might be wrong. So that's why, like, in order to mitigate that like risk of error, we're gonna use this one because cosecant is just the reciprocal of sine. So that's like almost 100%. Like we definitely got that correct, right? You just have to flip the fraction. So that's like pretty easy. So that's why I'm going to use this identity. And then finding cotangent, you take the reciprocal of cotangent, and then you get tangent. All right. So cotangent theta is equal to, let's see, cosecant squared minus 1 plus or minus square root. And remember, cotangent is positive in the third quadrant. So this is actually positive square root. Okay. And then just substitute in. So cosecant is the reciprocal, so negative 3/2 squared minus 1. And then if you were to evaluate this, you would get square root of 5 over 3. Or over 2, my bad, over 2. So therefore, cotangent of theta is equal to the square root of 5 over 2. And then tangent, you just hit the reciprocal, so you get 2 square root of 5 over 5. All right, boom. This is the answer. All right, cool. So now let's talk about some more identities. All right, so now we have the even odd identities. Okay, so again, let's look at the unit circle. Okay, so first let's look at sine. Okay, so notice if like so if we have sine of like theta like right here, right? So then this corresponds to a positive value. So and then if we like to flip this over the x-axis, you negate the angle, so this is negative theta, and you also negate the y value. So this is like, so if this was like some y, this would be negative y, right? So essentially, we have that sine of negative theta is equal to negative sine theta. So basically, if we take sine of negative theta, that's negative y, right? And then sine of theta is y. So so here, let me see. So sine of negative theta is negative y, right? From our picture, sine of negative theta is going to be negative y. And then negative sine of theta is positive y. So then you get negative y is equal to negative y. Check, right? So this is the first even identity. So basically, sine is an odd function. So sine of a negative of an angle is equal to negative sine. Okay, and again, you do not have to memorize these identities because if you ever need them and like you forget them, you can literally just build them like how I just built it right here. Okay, so that's sine, and then our next one is that cosine negative theta is equal to cosine theta. So let's build this one as well. So I'm just gonna like redraw my unit circle. Okay, so right here we have theta, and then right here we have negative theta. So notice that, so for like this one, the x value is like somewhere right here. So let's say this is like x coordinate x. And but then for this angle, like I didn't draw my circle perfect, but like it would be the same x, right? Like it should come like this. Okay, so it's the same x. So that's why cosine of negative theta gives you x, and then cosine of positive theta also gives you x, right? So you can kind of see from like the unit circle, like visually, that how that makes sense. So this is the second even identity. And so then now we can deduce that cosine is an even function because cosine of negative theta is equal to cosine of positive theta, right? So basically the sign of the angle doesn't matter for cosine, which is pretty neat. And then to get the even and odd identities for the rest of the trig functions, you can just build them from this one. So for example, tangent of negative theta is equal to sine negative theta over cosine negative theta, right? Because tangent is defined as sine over cosine, okay? And so that means that if we have negative theta, just put negative theta in there as well. But we already know the identities for negative theta, sine negative theta, and cosine negative theta. So we could just plug those in right here. So we get tangent negative theta is equal to sine of negative theta, which is negative sine theta. And then cosine of negative theta is just cosine theta. So then therefore, tangent of negative theta, so sine theta over cosine theta is tangent, and then we have a negative out front. So this is equal to negative tangent. Okay, and so then therefore, tangent is odd. So I'm gonna just like box my energies. Okay, and then to get the ones for cosecant, secant. So hold on, cosecant, secant, and then cotangent. So just know that the reciprocal functions, the reciprocal trig functions, have the same parity, like same even odd, as the parent function. So like, for example, sine of negative theta equals negative sine theta. So the reciprocal of sine is cosecant. So that means that cosecant follows the same rule. So that means that cosecant negative theta is equal to negative cosecant theta. All right. And then cosine is positive, or not positive, it's even. So that means that the reciprocal secant is also even. So secant of negative theta is just secant theta. Okay, and then similarly, tangent of negative theta is negative tangent theta. So tangent is odd, and so that means that its reciprocal cotangent is also odd. So this is equal to negative cotangent theta. Okay, so you can just build these even identities like how I just built them. Okay, because mainly you just have to build sine and cosine from the unit circle, and then everything after that you could just build from whatever you derived, right? Super easy. All right, so now let's do another example using these identities. All right. So example 3. Find sine theta and tangent theta if cosine of negative theta is equal to negative root 3 over 4 and sine theta is greater than 0. Okay. So the first thing I want to figure out is this quadrant that we're in. And so let's just use ASTC. So we're given that sine theta is greater than 0, right? So immediately we can eliminate quadrant 3 and quadrant 4 because in those two quadrants, sine is negative. So that means that we're either in quadrant 1 or quadrant 2. So if we're in quadrant 2, then that means that only sine is positive and cosine is negative, which it is. So, oh, and then first of all, we can use our even odd identities to simplify this, right? Because we know that cosine of negative theta is equal to cosine theta, right? Because cosine is an even function. So really, this is just the same thing as saying cosine of theta is equal to negative square root of 3 over 4. All right, so that's where those even odd identities come into play. And so now that we have cosine, and we can see that it's negative, so that means that we can't be in quadrant 1 either, because otherwise it would be positive. So that means we're in quadrant 2. All right, cool. So now that we have that all sorted out, we can actually find sine and tangent. So we're given cosine, so to find sine, we can just use that first identity, sine squared plus cosine squared equals 1. And then solving for sine, we get sine is equal to the plus or minus square root of 1 minus cosine squared. But we're given that sine of theta is greater than 0, so this must be positive. All right. And then substitute in the value, you get 1 minus negative root 3 over 4 quantity squared. Okay? And then if you were to evaluate this, you would get that sine theta is equal to square root of 13 over 4. All right, cool. So now we just need to find tangent theta. So we know cosine theta is negative square root of 3 over 4. Okay, so then we can find the reciprocal of cosine, namely sine or secant, and that's equal to negative 4 over square root of 3. And there's no need to rationalize here yet because like we're just going to square this eventually. So like rationalizing it right now is just like extra work, right? So we don't need to rationalize it. But then let's see, let's use our identity. We have 1 plus tangent squared is equal to secant squared. Okay, and then solving for tangent. So tangent theta is plus or minus square root of secant squared minus 1. So is it positive or negative? Well, we're in quadrant 2, so that means that only sine theta is positive, and then cosecant is positive. So that means that tangent must be negative. So this is negative. Okay, and then we can substitute in. So we will get negative square root negative 4 over root 3 minus 1. Okay, and you will get negative square root of 39 over 3. Okay, so yeah. All right, so basically the only difference with this problem was that we were given cosine of negative theta instead of just cosine of theta, but that was no problem because we used our even identities and we knew that cosine was even, so we just switched this immediately to cosine theta is equal to that, and then we just proceeded like we did with the other problems using the Pythagorean identities. So yeah, that's pretty much it for this part 1 trigonometrics. If you enjoyed this video, please make sure to leave a like and don't forget to subscribe. I'll see you guys in the next video.